Hey everyone, so here's your first 15 minutes of review for your test on the Thursday that you get back. So this is the review sheet. I'm going to do all of them, but pretty much like if you see something that we haven't done before, we're missing one thing, which is the absolute value. I may skip over those and go over those on Monday, okay? So let's look at number one. Now, you guys, this is the U sub test, which means most of what you're going to see on your test will be U subs, but there may be stuff that aren't U subs too. So we'll kind of talk about when to use them and when not to. Okay, so let's look at number one. You have the integral from 2 to 4 of dx over 5 minus 3x. So the question is, do I use a U sub or not? Well, one thing that I do see here that I don't like is I have this dx on the top. Remember what I said with those? Like shove it over to the side so it looks a little bit better. So this is really going to be the integral from 2 to 4 of 5 minus 3x on the bottom, and then the dx on the side, which means there's a little 1 on top here, right? So I have 1 over something. When I have 1 over something, think of like 1 over u, right? That's the ln. So let's go ahead and do u sub and see what happens. So if my u is going to be this whole bottom part, this 5 minus 3x, then my du, the derivative, is going to be negative 3 dx. So let's go ahead and rewrite it and see what we get. So let's do the substitution. I'm going to have the integral of 1 over, now the u became the 5 minus 3x, so it's going to be a u. And then I still have this dx that needs to be replaced, but the dx just equals the du, which means I have this left over negative 3, which means I have to multiply by negative 1/3 on the outside. Now, I'm not quite done yet because I have to change my boundaries. So I'm going to plug 4 into this x. That's going to give me 5 minus 3 times 4, or 5 minus 12, right? Which is negative 7. So my new upper boundary is negative 7. If I plug in the 2, I'm going to get 5 minus 3 times 2, which is 5 minus 6, which is negative 1. So now I've got my new boundaries. Everything's in terms of u, so let's go ahead and integrate. So what am I going to get? This is negative 1/3. The integral of 1 over u is the ln of absolute value of u, and then I'm evaluating from negative 1 to negative 7. Okay, now one thing that some people do is they go, well, do I need to change this u back into x's? I don't, because these boundaries I changed into u's. So that's the nice thing about changing everything into u's. So let's go ahead and plug them in. If I plug in the negative 7, okay, I'm going to pull this negative 1/3 out so I don't have to deal with it. I'm going to have the ln of absolute value of negative 7. Well, the absolute value of negative 7 is just a 7. And then minus the ln of, if I plug in a negative 1, the absolute value of negative 1 is 1, so I get ln of 1. And you guys remember, maybe make flashcards of this. The ln of 1, oops, sorry, I didn't write the 1 in there. The ln, what is going on? Sorry. The ln of 1 is 0, and the ln of e is 1. Please, please know this for this upcoming test. It's definitely on there. Okay, so if I know that the ln of 1 is 0, this is really gone. So it's just negative 1/3 ln of 7 is my answer. Okay, and you guys, if you're looking at this, that's going to be b, right? Do you see the 1/3 in here, 1 over 3? Okay. All right, let's look at number 2. F is a continuous function. It says f, big F prime of x is little f of x. What is the integral from 2 to 6 of f of 1/2 x dx? Okay, so what I would do on here, first I would do a little u sub here, okay? Because it's talking about little f of x, but this one's a little complicated. So I'm going to do a little u sub. So if my u equals 1/2 x, then my du is going to equal 1/2 dx. Okay, so if I do a substitution here, I'm going to have the integral of f of the u equaled the 1/2 x. Okay, then I still have to replace this dx. So my dx is du, but I have a little left over 1/2, so I'm going to multiply by its reciprocal, which is 2. But I still need to change those darn boundaries. So if I plug a 6 into here, half of 6 is 3. And if I plug a 2 into here, half of 2 is 1. Does that make sense? Okay, now here's the question, like what do I do? How do I integrate this? I don't know what the integral of f is, but you guys, if you look at what they gave you right here, they told you that big F prime of x is f of x. So the question is, what is the integral of the function? That's what I'm looking for. Well, let's integrate both sides, right? So if I take the integral of f of x, remember an integral and a derivative cancel each other out. So really the integral of little f of x was just that big F of x. Okay, now it doesn't really matter if these are x's or u's, it's just a variable. So check this out. This is 2 times the integral of little f. The integral of little f is big F, so this is big F of x, or it's a u this time, sorry. And I'm evaluating from 1 to 3. So if I plug this in, I'm going to have 2 times big F of 3 minus 2 times big F of 1. Okay, and so that gives you A as an answer. I know that one's kind of funky. I believe we did that couple examples like that on Friday, so it's pretty new to you guys. All right, let's look at number 3. Which of the following definite integrals has the same value as the integral from 0 to 4 of x e to the x squared dx? Well, the only thing they did was a u sub. So they're just saying u sub this and don't evaluate it, but let's just find out what it is when you u sub it. Okay, so what do you think your u would be on this one? I would have a big hunch that it's still a little x squared. Okay, then your du becomes 2x dx. And then if I do my substitution, I'm going to get e to the x squared, which is my u. But notice I still have this x dx left over. Well, here's my x dx. That's going to become my du. And then I have this leftover 2, so I'm going to have a 1/2 in the front. Now, you guys, just by looking at the answers here, it's not going to be C, D, or E. I need a 1/2 in front, right? So what's the difference between A and B? Well, it's their boundaries. On one of them, they changed the boundaries. On the other one, they did not. I need to change my boundaries. So I need to plug the 4 into here, giving me 4 squared, which is 16. Then I need to plug the 0 into there, giving me 0 squared, which is 0. So it's 0 to 16, which gives me an answer of B. Okay? All right, let's look at number 4. So on number 4, we have dy dx equals tangent x, and what does y equal? You guys, another way to write dy dx, this is a fancy name for y prime, right? Equals the tangent of x. So all they're asking you to get to y, you just need to integrate it, right? An integral of a derivative cancel each other out. So have y equals, and what's the integral of tangent? Well, I don't know. I don't know what you take the derivative of to get tangent. So we're going to have to do a little bit of, I don't know, changing here. Tangent, I know, is sine of x over cosine of x dx, right? I think this was on your homework, just written a little bit different way. Now let's u sub this. I'm going to make my u my denominator, which is cosine. The derivative of cosine is negative sine of x dx. So if I u sub this, I'm going to get the integral of, the u became the cosine, so this is my u, so there's a u on the bottom. And then notice my sine x dx, all of that became the du. So I have a little 1 left over on top, I have a leftover negative, I'm going to go ahead and pull that out. Okay, now what is this? It's going to be negative, and then it's going to be the ln of the absolute value of u plus c. But we know that the original u was a cosine of x. So it's negative ln absolute value of cosine of x plus c. Okay, so looking at this one, what have we got? Oh my gosh, okay, this is a tricky one. A lot of people would go, well, I must have made a mistake somewhere, so the answer is this. But it's not, because I have to have a negative in there. I know it's not this. I know it has to have an ln in it, so it can't be these guys. So like process of elimination would be like it's C, but how the heck is it C? So do you guys remember? We did this on Friday, okay? I can write this, instead of writing a negative, I can write negative 1 ln of absolute value of cosine of x, right? I could do that. And remember, this little guy used to be an exponent that was flying up here. Do you guys remember that? So another way I can rewrite this is ln of absolute value of cosine of x to the negative 1 plus c. Now, what does cosine of x to the negative 1 really mean? Cosine x to the negative 1 is really 1 over cosine of x, which is really the secant of x. So I can rewrite this as the ln of absolute value of secant of x plus c. Okay, pretty darn gross, but that's what the answer to number C is. All right. So you guys, what I kind of challenge you to do, because I'm not going to get through this whole review sheet, but maybe like if we get to the back here, I'll give you guys a couple to try from the back that were similar to what we did today, like just some basic U sub questions. Maybe like from the back page, maybe you guys could do, I don't want to do that one. That one's weird. Maybe try like number 38 and then check your answers. That's a nice little U sub. So here your U would be x squared plus 1. Go from there. See if you can get that answer. We did something like that today. And then maybe if you want to, you could try like a number 36 is kind of a cute one. Okay, what would your U be on this one? It'd be 3x squared plus 5. That one works out really nice as well. And then if you really want to, maybe try like number 35. So the U sub on this one would be x squared plus 2x. Give those three a shot. Check your answers with the answer sheet that I gave you and see how you did. All right? Okay, you guys have a good day, and I'll see you guys on Tuesday. Well, I'll talk to you on Tuesday.